Hey guys, welcome back. So this is the second part of the presentation for building decentralized applications on top of Injective. And to recap, in the first part we've built Dexly, a fully functional decentralized exchange, and also included a bridge from Ethereum to Injective. So you can find the source code for, I'm going to link the source code for Dexly in the presentation itself, so you can always reference the implementation if you need any help. Again, one important note is to make is to always reference the Injective TS wiki. We have a lot of information there, and obviously you can always send us a DM or find us on Discord and Telegram if you have some questions or there's something that you need clarifying. Okay, so the part 2 of this presentation is to make a simple smart contracts decentralized application. To give a little bit of more context, after the introduction of the Cosm Boson layer at Injective, we've seen some great and innovative work being deployed in the form of smart contracts. For example, the Astroport app, White Whale, and a lot of other decentralized applications that are that developers are building. For this example, we are going to build a simple UI around a pre-existing simple counter smart contract to showcase how we can interact with smart contracts using Injective TS. And you can find the repo here, the smart contract here on this repo, and I've opened it for you. It's CW counter, it's a public repo, and the smart contract itself is within this contract.rs file. And here you can see what you can do with which functions you can execute on the smart contract itself. It's the increment and reset function, and you can query the count itself. You can query the state of the smart contract by querying the count of the counter. Okay, so again, let's build it together. Before we start building, let's define the scope as we did for the previous app. For this app, we are going to allow the user to connect their wallet. We're going to fetch the smart contract state, and we're going to interact with the smart contract by making a transaction. We are again going to use MetaMask to make things a bit simpler. And start building the smart contract UI. And for this example, I'm going to skip the configuration. We're again going to use Nux3, but I'm going to skip the configuration and focus more on the implementation itself, like how the stores work and like build the components without skipping the writing the HTML and CSS. So I'm going to deep dive a little bit more into this application because I think it can be a nice way for developers to reference how to build components, how to build stores, how to just connect the UI with the stores themselves and the application logic in the end. Okay, so let's go back to the code editor, our second home, and I'm going to pause the video and configure the Nux3 UI. Okay, so now that we're back, I've defined a couple of stuff. We have the same services file in the app folder. We have the wallet strategy, the message broadcaster, we don't need the indexer spot API. We are going to need the JNGRPC WASM API because this is the API that we use to query smart contracts. And just like before, we have the Alchemy RPC endpoint and the WebSocket endpoint. And one thing that's new here from Dexly is the smart contract counter address deployed on testnet, which we can use out of the box. And you can go to testnet.explorer .injective.network, and I can just search for the smart contract details, and I can see the smart contract details on the Explorer itself. You can see the count is 99, so we're going to confirm that on our UI. Okay, let's boot the app. Let's just see it's working. I made one page. The index page just says hello from the UI. Let's see. So this is working, and we also have the wallet store, which I've ported from Dexly. It's just a simple way to connect to wallet strategy and get the addresses. We also have same configuration as before, just following the Injective TS building dApps configuration using Nuxt. Okay, let's start actually building the layout. First, we are going to have, let's make the background gray 100, and then on the top we are going to have the header. Let's make it a comment, then we have the content, and then we have the footer. Right. So first we're going to need like a couple of components to use. We can have, let's make a new folder, components. Since we want to have everything centered, let's make a container component. It should be just a simple wrapper component that basically just uses Tailwind's classes to, actually we can just build it on our own. So it's centered, and then max width is like 6 XL. Then let's just add some padding, and then in the slot we have the actual content. Then we also want to have a card component just to stylize a little bit, just to make the UI a little bit more stylized, so it's not that simple as Dexly. So it's just again some simple div that has a, let's make this white, let's add some shadow, add some padding, and make it a little bit rounded, and then the slot inside. Then we will also need a button component, and for this we can actually like copy some implementation from the Tailwind CSS. So let's just copy this one. I think it's pretty good. And again, we can have a slot here just so we can add the text from our parent component. Actually, I'd like to make blue 900, make this blue 600. And then finally, we will need a button to connect the wallet. So connect wallet view, which will basically we will have two buttons. The first one would be to connect the wallet. Let's just make this, actually that's fine. So with capital B we're going to call this component, and here we can have connect wallet, and this is only called if wallet store that is wallet connected. So if the user is not connected, we don't need to call it. Let's set up the script. So it's like TypeScript always. Let's use the wallet store. Sorry, use wallet store. Wallet connected, and then what we could do is okay, so once the user is connected, then we can just show the user his address, and we can use a small utility function that we have in the SDKTS. Format wallet or format address. Maybe yes, or utilities. Let's see where it is. Yep, it's in the utils. So let's make a computed property, formatted wallet address, and then just return the wallet store, that address, but format it so we don't see the whole address, right? Like this. And here we need to add a handler. So when you click handle connect wallet. And what we could do is just make a simple function here that just calls the connect wallet on the wallet store, and if we catch, we can just pass alert to alert the user about some issues we may have encountered. Okay, so now that we have these couple of components, let's start building the page itself. So first, in the header, let's add the container, and we can style it a little bit more. So let's make it a little bit wider on the height. Let's also make it flex, and then just step right between and center the items, and we can just have a logo here that says counter UI, and here we can have the connect wallet component that we've just built. So if I go back, let me just start the app. As you can see, we have this, but let me just check why Tailwind is not included. Maybe we forgot the module. Yes, we did. So let's add Tailwind next here. Let's rebuild. We don't have it installed. Okay, let's add it. Modules. Okay, let's build the app now. Okay, let's see. Nice. So we have the counter UI and we have the connect wallet button here. If I click, voila, I just connected to my MetaMask wallet and I can see the address here. Okay, nice. So now let's build the form itself. Let's go back to the index page. Let's have a container here. And then here we have a grid. Let's center the items and add a little bit of padding. Then inside we'll have a cart, and here we can start making the form. And on the footer we can just say copyright copy Injective Labs. Okay, but let's just make the layout to be max height screen, and then we can flex call, flex wrap, and here we can just do full and put the footer here and just place it on the bottom, and the text center, text set. Let's just make this a little bit darker here. Okay, let's make this main age screen. So actually, let's move it from here to the page itself. to have one div that contains all of the content, which is full height, and then the footer, which will be down below. Nice. Okay, let's make this white so we can separate it from the footer itself. Actually, not this one. So we can make just the header actually white. Okay, and we added flex one here, so it expands to the whole height of the screen. As you can see here, we have the card, so let's start filling it in. First, let's build the forms header. Here we can say h2, center it, make the text a little bit higher, and then the count is. Here we can have the count, and h3 here. We can have some class as well for the counter itself. Let's make it a little bit bolder, center it again, and here let's add a status. Let me make the script. I'm going to import status from utils. This is one abstraction class that we have for managing statuses on the UIs. So let's just do status new status. We can make it reactive. Then new status type. We can make it loading on the beginning because we want to load the count when we when we create the component, and then unmounted. Fetch the count, and then obviously set idle. Set the status to idle. We are going to have the count itself, but it will be coming from because we want to have the same architecture. The user makes an action. In this case, he will open the index page. We make a method call on the counter store, which we are going to create, which we created here, and this counter store will perform the action itself. It will fetch the smart contract state, and it will update the state of the counter store, and this will be reflected on the UI. So here the count will actually be count computed, and then we just return the counter store that, let's import it here first, counter store use counter store. Here we can just do count, and then this is the count. And here if the status is loading, then we do something like loading, and if not, actually we don't need it here. We can just show it here. Okay, and then below we can have a button that's disabled on loading, and on click we can handle increment the counter by 1, and here let's make it full width, and here we can just say plus. Actually, we can do plus. Let's make this function here, which we're going to do later on together. So now we are just building the UI first. And then we can also set the counter by some value. We can do this by calling the set method on the counter contract, but there is one caveat here, is that you can only call it if you are the owner of the contract, or aka the address who deployed the smart contract itself. So if we call it from some address that's not the deployer of the contract, it will just be unauthorized transaction, and you will not be able to reset the state. So let's just do that now. Let's add some stylings. Here we are going to have an input. I'm just going to copy one of the implementations I already have, so we don't spend a lot of time on this. Here we're going to have a function called setCount. We're going to do it after, and we are going to just have a number ref for the form itself, which we want to pass to the transaction that we are going to make for the setCount method. And here we are going to add a watcher that's going to watch the count from the counter store, and then we are going to update. Actually, let's just make it the string, and it's going to update the number within our component. And this is to just update just to update the vModel value within the input. So when you update, let's say you increment the counter and it increments by 1, then we are going to update the number ref here by 1, and it will be updated on the input field itself. Okay, so we have something here. Let's see how it looks like. It looks pretty okay, it's a simple app. So now let's start wiring up the logic itself. First, what we want to do is fetch the count. So this is so we need to perform we need to query the state of the smart contract on the COSM-WASM layer. So let's do that. On mounted, we can do. Let's make a function. Actually, we don't need a function because we are going to call the fetch counter function within the counter store. So counter store fetch count. This is undefined because we haven't defined it yet. So let's start working on it. Fetch count. We just do counter store, use counter store. We need this to patch the state. Then using the response chain WASM API, then we do fetch smart contract state, and here first the argument is the contract address, the counter contract address, and then the query that we want to perform, and it needs to be in base 64. So we have one utility function on the SDKTS, and here we pass the object that we want to convert to base 64. And for this particular smart contract, we want to query the getCount method. So now that we have the count, we can make this count. Actually, it's response because it's when we fetch it, it will return base 64 again. So now we need to convert it back to a readable number. So it's count. It will return an object. It will return a response that has a count field. So we can do from base 64, and then because this is a uint array, let's await here. So this is a smart contract response. Sorry. And the data itself is uint array. So we need to convert it from uint array to base 64. And this will give us the count itself. So this is count number. And then we are just going to counter store patch the count. Okay, nice. So let's call this and see whether it works. We call it on fetch count, mounted. So let's refresh. Counter is 0. Okay, contract not found. Let's see what's the problem. Oh, I think we set the chain ID to mainnet, but we needed to be testnet actually. We can use testnet K1s here. It's not. It's Gorley. Okay, let's rebuild the app. I copied from the Dexly, but we are operating in the testing environment for this smart contract UI. Okay, let's refresh. And as you can see, counter is 38. Nice. Okay, so now that we have this information, we loaded the smart contract state, and you can see the call being done here. And as you can see, it's returning the count 38. Sorry. Okay, so now that we have this the count, we can do two transactions. The first one would be to increment and the set count. But before we do that, we need to also while we do these transactions, we also need to check whether the user is connected or not to his wallet on our decentralized application. Okay, let's go back. So now within the index page, we basically need to fill out these two methods. The first one, so first we need to set the status to loading. Loading, and then on the counter store we need to call a method called increment, and then obviously catch alert, and finally status set idle. Here we are going to do the same with actually set count. But here we are also going to introduce some validations just to ensure that the user's number that they enter is correct. So one restriction that the counter has is the number must be between -100 and 100. This is done just for this example. And obviously we need to make sure that the number is a valid number. So here we just pass the number itself. So let's build these two methods now on the store. Let's go to the store. So we have the counter store, and we have the first action would be increment, and then we are going to use the wallet store, and we are also going to use the counter store if we need to update the state. So let's just first check store is user wallet connected. If not, we are just going to throw a new error, user is not connected. And if everything's okay, then we just like we said before, we need to create the message, prepare the transaction, sign it, and then broadcast it to Injective. So let's create the message. When we want to execute a smart contract, when we want to execute a method on smart contract, we use the message execute contract compat. There are two versions of this message. One is without the compat, but this one is not compatible with MetaMask, so you have to use compat if you want to use MetaMask, and then we just pass the arguments. The contract address is the contract address, the sender is the wallet store, the Injective address, the address, and then what we want to do is increment the message that we want to execute on a smart contract is to call the increment method, and we don't need to pass any arguments because it will just increase by 1. And then it's just quite easy. We just message broadcaster, broadcast. Here we have the messages. It's the message that we want to send. And the injective address is the wallet store address. Just to make sure, because smart contract execution can, when we query the, we want to query the new state. So we are going to make a small buffer here. Let's say we wait for the smart contract to update its state and then like sleep for 5 seconds, and then we are just going to call the store fetch count again. Okay, so similar to this, we're going to create the set count method, but with one small difference. The count is passed here as a number or a string. That's not a big deal. And the message that we want to execute on the smart contract is within the reset function, and we also need to pass the count that we want to set the counter to. So we are going to parse the count from string to integer, and here we just do the same. Quite easy, huh? So let's go back. We have the functions, we have the functionality, everything is wired up. Let's go back, let's see if everything works. So counter is 38. Okay, so user is not connected. We need to connect the wallet. I just connected my wallet. I have MetaMask popping here. Yes, this is on Ethereum. I need to change to Goerli because this is testnet. Okay, and then I click on plus. Actually, let's refresh. So, user not connected. I connect my wallet. I increment. I sign the transaction. Let's wait a little bit for the transaction to be included and also to like refetch the counter. And as you can see, it's 39 now, and I have 39 here. And then if I want to call the set count, let's say I want to set it to minus 100,000, whatever, just the validation that we have, and let's just use 50 here. Set count, but as we've said before, this transaction will not pass because we are not the owner of the smart contract. So if I do sign, I get unauthorized error because I cannot call that particular method. Okay, so that wraps it. We've seen the smart contract UI. Hopefully it was fun to build these 2 decentralized applications with me. If you have any questions, feel free to reach out, and always, as always, I'm maybe boring with this, but reference the Injective TS Wiki. We spend a lot of time building it and writing all of the examples, so this will be your home for the duration of the hackathon. Okay, nice talking to you. Peace.